What is eccentricity? Eccentricity is a measure of how much the conic section deviates from being circular. It is a number between 0 and 1, 0 being a circle, a perfect circle, and 1 being very eccentric. Eccentricity can be used to find a number of things. Among them are orbits of planets around the Sun. The formula to find eccentricity is E equals F over A. But we don't know what it's F, we don't know what it's A, so let's find out. In a conic section, more specifically an ellipse, we have two focuses and a center. F is the distance between the two foci of the ellipse or circle. We also have A, which is the measurement of the major axis of the ellipse. Knowing this, we're able to draw and calculate many orbits around the Sun, such as Earth's. People are very accustomed by the idea that Earth's orbit is very eccentric, but actually it only has an eccentricity of 0.02. In order to correctly draw the orbit of the Sun, we're going to use eccentricity. E equals F over A. We're going to rearrange this equation in terms of F, and it is going to result into F equals E times A. We determine A as 2 equals to 15 centimeters, and we plug it into the equation to find F. F equals 0.02 times 15, therefore F equals 0.3 centimeters or just 3 millimeters. F is the distance between our foci. Now we use this information to draw the ellipse by hand. First, we draw A in order to find the center of the ellipse, which is 7.5, as A is 15 centimeters. 15 centimeters divided by 2 equals 7.5 centimeters. In order to draw the ellipse without the aid of any resources, we need to determine another thing, which is B. B is the minor axis of your ellipse. We calculate B by using the following equation. B equals A times the square root of 1 minus E squared. Now we plug in the information we have. B equals 15 times 1 minus 0.02 squared. Therefore, B equals 15 times the square root of 0.996, which equals 14.997. Therefore, B equals 14.997. Now we have gathered all the information necessary to draw the ellipse. This is the orbit of Earth in comparison to the Sun. To calculate and draw the ellipse of Comet Halley, we look at its eccentricity. Its eccentricity is actually very high, it's 0.9. Very high in comparison to the Earth's, which is just 0.02. We manipulate the equation again into terms of F, which would equals F equals E times A, and we use this constant A of 15 centimeters so that we can fully see the difference in that eccentricity makes. F equals E times A, which gives us F equals 0.9 times 15, so therefore F equals 13.5 centimeters. F is the distance between the foci. As we're drawing it by hand, we need to find B. B equals A times the square root of 1 minus E squared. B equals 15 times the square root of 0.19, and therefore B equals 6.538 centimeters, which is our minor axis. Now we actually draw the ellipse. We start by the major axis of 15 centimeters, then the minor axis of 6.538 centimeters, and we can draw this axis by using the center, which is 7.5 centimeters. Then we add the foci in both ends, and finally we draw the ellipse. So this is all you need to know about eccentricity, and how to draw orbits of planets.